Well, hey, chemistry kiddos. How do we use Charles's law? We know that volume is proportional to temperature. In other words, if volume increases, temperature increases. If temperature increases, volume increases. And that makes sense. If you have a flask, and you'll see this in class, and there's a balloon on top, that balloon is going to expand when the temperature increases. Well, why? Because we're making those particles move faster, they have more kinetic energy, and thus volume goes up. Now, it does seem kind of weird to think of it this way. So what if you have a balloon and all the gas is right in there? And then all of a sudden the balloon is this big, but the gas is still right here. Well, what's that gas going to do? Well, it's going to spread out. It's going to start to move. Now, I don't know about you, but when I start moving more, I heat up. So as volume goes up, temperature goes up. So let's take a look at Charles's law. Charles's law is V1 over T1 equals V2 over T2. Whoops. I am messing up here, y'all. Okay, T2. My brain's getting a little fast here. So let's say we've got a gas and it has 25 liters at 25 degrees Celsius. What would be the volume if the temperature went up to 73 degrees Celsius? Well, before you plug in, remember, you must convert temperature to Kelvin, because Celsius can have a 0 degrees, and you cannot put 0 in the denominator. So we have to go to Kelvin. Kelvin is more in line anyway with molecular motion, because 0 Kelvin is the theoretical point at which all motion stops. So really, truly, when you're talking about molecular motion, you should be using the Kelvin scale because it's more in line with that. So anyway, first convert your temperatures. How do you do that? You simply add 273. So that one's going to be 298 Kelvin. And then 73 plus 273 is going to be, let's see, 6, 14, carry the 1, 346 K. Now you can plug and chug. So 25 liters at 298 is equal to, well, I don't know, so we'll just call that V at 346. A lot of students get to this point and they started having a panic attack. Don't do that. Simply cross multiply. So you get 25 times 346 equals 298V. Now, if you want to simplify this right here, you by all means go ahead. Me, I like to do it all at one time. So I'm going to divide by both sides by 298, and we're going to get volume equals, well, if you do it on the trusty calculator, 25 times 346 equals, divided by 298, and you're going to get about 29. And I'm not going to worry too much about sig figs right now, but 29 liters. Now, one of the questions I get asked is, well, do labels matter? Well, yeah, you better be in Kelvin for temperature, period. And honestly, if the problem starts in Celsius, you probably should go back to Celsius at the end. All you have to do is subtract 273. But as far as volume, volume could be given in liters, milliliters, centimeters cubed, meters cubed, etc. And it really doesn't matter at all on this particular equation what you use. Where you do want to be careful is when we get into this equation. This is the ideal gas law. And because of that constant, we have to be careful of what labels we use. But we'll talk about that more when we get there.